Hello, welcome. I have developed one AI agent which can be useful for getting an insight into your performance test result. And I have hosted this as an open source project on the GitHub. Let us understand how we can take advantage of this particular project and you can use in your organization, in your project, for even for your learning and practice purpose. This particular tool executes the JMeter test, validates its SLA rules and generates the summary using local AI model or a cloud-based AI model such as DeepSeek or Grok or Anthropic Claude or Google Gemini, right? Any of the tools. Once you run the performance test, it will give a clean dashboard like this. JMeter test completed, dashboard HTML generated, and what is the path of the result, right? You can open the result from this particular file, and what are the metrics, right? Average response time, average throughput, error rate, right? Also here you can see 95th, 99 percentile and all those things. Then finally, based on the execution, it will analyze the report using the AI agents. Here it will give a clean insight. What is the thing? The system technically met all the SLA targets under extremely trivial load, it is telling, because I just used here 5 threads only. It is not the realistic test, just for the illustration purpose I used a 5. So it is telling trivial load, it is not a real load test. We need to increase the load. It is giving a clear insight. However, we observed response times are almost entirely consumed by the network connection overhead and time to first byte, indicating fundamental infrastructure boundary latency, not the application processing stress. It is telling there is a issue with respect to your network connectivity, or it can be server side bottleneck with respect to their network capacity as well. It is giving here bottleneck analysis, dominant infrastructure latency, trivial load, undetermined application performance, right? Some of the key findings it is giving here based on the test that we have run here. Also, it is providing here analytical key findings in a beautiful table format. Error percentage, we are setting up here error percentage, right? Maximum allow error rate is 5.5, but it is 0, so it is met our SLA target. Like this, average response time we have set as 2100 millisecond, it is 1302. It means it is met the our expectation. Similarly, peak outlier, that's a maximum response time, we set 5500, it is 1999. So all the things are met. So diagnostic server checklist, it is telling consistent high connection overhead, right? Time to first byte, right? Connection, basically it is pointing the network infrastructure related issues, not the application itself. So these insights will help you in troubleshooting your performance issues, where exactly you need to check in order to improve the performance, whether it's application issue, whether it is server issue, whether it's a network issue. Also it is telling about here, see, stability scorecard, throughput is good and latency is moderate, error rate is good, connection overhead is poor, connection establishment is taking more time, that's why it is telling poor here. Again, prioritized engineering actions, what is the actions that you can take now, fix now, investigate before the next run, what you can do. So it is telling design and execute a follow performance test with significantly increased load, because we have executed just using 5 threads. The issue is lack of meaningful application performance under stress. If you use just 5 threads, it will not give a meaningful result. So all these things it is giving. Also strategic recommendations, right? By using these tools, you can get all these benefits whenever you are running your performance test. Now let us understand how you can use this application in your local system, or even you can host in your own server. First thing is, this is a GitHub repository link, right? This is a GitHub repository. I will be providing this link in the description. So what I will do is I will copy this, either HTTPS or SSH, you can copy the link and then go to any folder. I created one folder called AI agents, and I will open the terminal here, or in your Windows you can open a command prompt. Then you can clone this, or you can directly download here as well. Code, you can download the zip file and you can use it. But for now, I will clone it using this particular URL. You can use any of these. Either you can directly download this zip file and extract the zip file and use it as well. So now I have opened the terminal. I will just clone it, git clone. So let us wait for this git repository to complete the cloning. Now 100% cloning is completed. Go inside this particular folder, and then you need to rename this file. If you don't rename, it will be creating another env file. That is also fine, but better practice is I will rename it. So in order to avoid another duplicate file, I will just rename this. Rename. I will remove this example and dot. This file is renamed now. Now we can go and read the instructions here. Here we have seen how to download. Here you can do direct download or using a clone. We have done this cloning using this HTTPS or SSH. You can use either of those. So now next step is you need to create the JMeter script and you need to name your test plan as a testplan.jmx and place it inside this folder. I have already placed a sample test plan here, right? You can open the JMeter and you can create your own test plan and you can place whatever the test plan that you want to run. You can open the JMeter and you can create your own test plan and you can place it here, right? For now, let us keep this name as it is, test_plan.jmx. We have already discussed how to create the test plan in JMeter, right? So JMX file creation we already know. We will just place the created test plan here under this particular folder. Now you can launch the application. To launch the application, what we need to do? We need to use this command for Mac. If you are on Windows, you just have to double click on this file, start windows.bat file. This file is this one. This is for Windows and this is for Mac, this particular command. So I will copy this command and you need to go inside this particular folder, perfinsight.ai. Here I can open the terminal. So I am in this particular folder here and then I will run this particular command. So it will check any dependencies. If it is not present, it will create a sandbox environment or a virtual environment and it will install all the dependencies which are necessary for running this project and it will launch the application. See, now it is launching. It is using here 8052 port number. So let us wait for application to load. Now this application is loaded. So what are the things that we need to do here? So for example, this is the path to your jmeter.bat or jmeter.sh file. That is, you need to check where you have installed your JMeter. So this is my JMeter folder. Inside JMeter, go to bin folder, search for JMeter. If you are using Windows, if you are running this application on Windows, you need to provide the path to this particular file, jmeter.bat. I am running this on the Mac, so I will provide the path to this particular file, jmeter.sh. I will just copy this path name and provide this path here. Now the test plan, whatever the name of the test plan that you saved in the root directory, here if you go, we have saved it as test_plan. Same thing, I will keep it here, and result CSV file where the result will be saved under this report folder. It will save as a result.csv. So right now there is no report folder. Once you run, it will create the folder. Now you can set here what is your average response or a maximum response time. For example, I will set here, like, let us say average response time to be 1500. I want error rate to be less than, let us say, 4%. Peak response I want less than 3500, and I will save this first. Also here you need to provide the API key. Here you can select different models, Anthropic or a custom OpenAI compatible, Olama, OpenAI, right? Different AI providers you can use, and for each AI provider, what is the model name key that you need to key in is provided in this particular table. There can be some different models available later on as well. You can use that model. For example, I am using Google Gemini now, so I will select Google Gemini here, and then model is, I will select this 2.5 flash. This one, this is a free model, 2.5 flash. It provides some free limit, and you need to create your Gemini API key. And if you are using some other, let us say some other model, then you need to key in this base URL as well as per this URL that is given here, right? And if you are using, let us say, local Olama, then you need to provide this particular path and what is the model that you are using locally on the Olama, right? Whatever the model that you are running, based on this table, update the details. For the illustration purpose, I will be using Google Gemini, right? It is a very good model which is available free for certain limit. So Gemini 2.5 Flash. Here you can search Gemini API key free, right? You can get Gemini API key. So here you can click create or view Gemini API key. Here there is a one button here, create API key. I will create this API key. I will call it as PerfInsight AI. So default project I can select here. So this is the API key I will be using. This API key is a secret. Do not share it with anyone. I will be deleting this API key after this video is completed. So if you use this same API key, it will not work for you. You need to create your own API key. So now I will provide this API key here and then save. Once you save these things, it will automatically get saved in this particular env file. If you open here, you can see here API key is saved here, right? And here model provider Gemini, everything will be saved. You don't need to touch this file. You can directly update here in the UI easily, right? Now everything we have done. Test plan we created, path we have provided, right? It's a one-time setup. Next time if you don't change it, this default setting will remain as it is. So now let me run this performance pipeline. It will be executing your JMeter test plan. The execution is complete. Now it will generate the HTML dashboard as well. So here you can see it is giving alert, high average response time detected, mean metric is 1935, broken by safety threshold of 1500 millisecond. We wanted here 1500 to be average response, but it has broken that average response threshold, right? Like this it will give a meaningful result here. Here you can also check what is the 95th 99 percentile, right? Data sent, data received, total requests. So this is the stage 3 wherein AI agent will do the analysis of your performance test and it will provide the recommendations. The system failed its core response SLA even under extremely low load due to significant connection establishment and initial processing overhead. The primary architectural takeaway is that fundamental setup or initial request handling is severely unoptimized for responsiveness. In this my performance test plan, I have created using this sample test plan. I created using JPEG store application, which is quite slow sometimes, the application. So that's why probably it has broken this average response threshold, and maybe they have a limited server bandwidth capacity. So it is giving here more meaningful results. You see, excessive connection overhead. Average TCP handshake is taking 67% of the total average response time. By going through these insights, we know where exactly is the problem, where we should act in order to improve the performance of this application. Here you can see average response time is breached. Here you can see it is giving a cross symbol, right? Error percentage is less than 4. Here it is meeting the requirement. Here also it is meeting the requirement. What is this? Timeline diagnostics and server checklist. It is telling persistently high connection overhead and TTFB, that is time to first byte. Here you can see network and OS. Review the TCP IP configuration, firewall rules, loopback performance for local environment. For application server, analyze the startup sequence, connection handling logic, server side resource initialization, thread pool settings, right? All these things we need to review on the server side. On your local machine, you need to check your TCP IP configurations, firewall rules, right? All this properly configured. So where exactly this connection delay is happening, and you can also monitor resource utilization, monitor CPU, memory, disk during the connection and request processing. So it is also giving stability scorecard. Responsiveness is poor, error rate is good, scalability is poor. It is also giving the observations here. Here if you look at scalability, exhibits severe latency bottlenecks even with only 5 requests, suggesting a poor fundamental performance. Like this, it is giving a very useful results here. And by looking at these results provided in these tables, we can make a informed decision very quickly. So again, prioritized engineering actions. Fix now. What is the fix? So it is providing you the actions to take. Thoroughly investigate standalone local environment network configuration, OS level settings and application server binding. It is telling your local environment. You check whether it is properly configured for all your network configuration. Excessive connection overhead. That is the reason it is suggesting this. Perform detailed profiling of application server startup and initial request handling logic. It is suggesting this because time to first byte is very high. Indicator slow server side processing. It's also telling investigate this CPU memory usage, and before the next run, rerun the test with increased load and duration to validate the fixes comprehensively, access the sustained performance. Current test is too short, low volume for full performance profile. So this is the execution summary. What was our configuration target values for the test? Also, finally, it is giving a strategic recommendation. The observed performance at extremely low load points to fundamental architectural or deployment model inefficiencies. A strategic review should focus on connection management, example persistent connections, connection pooling, application pre-warning strategies to mitigate the initial request overhead, and potentially re-evaluating the standalone local setup representativeness compared to anticipated production environment. Long-term optimizing the cold start and first request experience is crucial for system responsiveness. So it is giving here a strategic recommendations as well. It has also generated your normal HTML report from the JMeter. If you go here, you can see report folder is generated, and this insight that you can see is already available here in the text file. It is generated here. And also JMeter report is here, JMeter HTML report. You can open this index.html. You can see this is normal JMeter report. This one is standard JMeter report which is generated, right? You can observe all the charts, everything here. So this is the dashboard. We have just used 5 samplers here. So for the understanding purpose, you can use it in your project and you can try to get the insight from the AI. It will be very useful. Experiment with it, and you can provide a suggestion, and you can raise the issues here in the GitHub for improvements. Issues, you can go here on the project, you can raise a new issues, and let me know how this tool can improve your performance testing and performance engineering experience. You can try using this tool, you can experiment with it, you can use in your project, in your organization, you can showcase it to your team, to your manager, and try to improve your performance testing and performance engineering experience to get a better insight on your performance test. Let me know what you feel about this tool. I will provide the link to this repository as well. I will try to come up with some useful tools for improving a performance testing and QA experience and a performance testing workflow or a QA workflow. Right? Thank you for watching.